goes. Okay, let's see, what do we have here? Camp cleanup. Space needs to be cleared before the last supplies can be unloaded from the ships, and to several elves have been assigned the job of cleaning up sections of the camp. Every section has a unique ID number, and each elf is assigned a range of section IDs. Okay. However, as some of the elves compare their section assignments with each other, they've noticed that many of the assignments overlap. To try to quickly find overlaps and reduce duplicated effort, the elves pair up and make a big list of the section assignments for each pair. Your puzzle input. For example, consider the following list of section assignment pairs. Okay, it's a list of comma-separated pairs where each pair is separated with a dash. For the first few pairs, the list means within the first pair of elves, the first elf was assigned section 2 to 4, sections 2, 3, 4, while the second elf was assigned sections 6 to 8, sections 6, 7, 8. The elves in the second pair were each assigned 2 sections. Two and 3, 4 and 5. The elves in the third pair were each assigned 3 sections. One got sections 5, 6, 7. This example list uses single-digit section IDs to make it easier to draw. Your actual list might contain larger numbers. Visually, these pairs of sections assignments look like this. Okay, yes. Oh, there is an overlap. Some of the pairs have noticed that one of their assignments fully contain the other. For example, 2 to 8, 3 to 7, yes. One elf in the pair would be exclusively cleaning sections their partner will already be cleaning. So this seems like the most in need of reconsideration. In this example, there are 2 such pairs. How many assignment pairs does one range fully contain the other? Okay, so there's today another set manipulation problem. So we want to check if within each pair of assignments we have one set fully contained in the set of the assignments of the other. Yes, and so how do we do this? Let's start by copying the input data. Okay, so how are we going to model this? We have lines with pairs with ranges. So what get is we have ranges and we have a vector of range and range. Okay. So we get a line, and then we split the line on the comma. Oh. There we go. So we first get left range is line substring 0 to pose, and the right range is line substring pose. Ah. 1, 2, 3, 4, 5, 6. Ah, I got the comma too. So I need, of course. There we go. And now we are going to do, 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 do. Okay, maybe I could, oh, never mind. So the left reined substring yeah, okay. 0 2. So we can do a scoping this. It's a poor man's function. Two and 4, 2 and 3, 5 and 7, 2 and 8, 6 and 6, 2 and 6. Okay, and then repeat this for uh, 6 and 8, 4 and 5, 7, 9, 3 and 7, 4 and 6, 4 and 8. Okay, and this was in vain because I need these values. Let's remove the namespace. So now we can push this result, which is a pair of a pair A1, A2, B1, B2. Ah. So question is, how much do we have to? So maybe what? Why can't you just understand what I mean? Yeah. It's a lot of conversion here. Convoluted code, anyhow. There we go. Yes. Okay. So we have the data model. So now what we need to do is check if one of the ranges in the pair is fully contained in the other one. Okay. So let's try brute force here. So one range is within the other if first we loop can do like this. So let's see, what's the end goal? We're just going to count how many pairs does one range fully contain the other. Okay. So one range is fully contained in the other if the start is after the start of the other and the end of the first is before the end, before or equal the end of the other. So yeah, no. Let's do it like this. Like that. And we can have the other way around. So we have think we need some tracing here. So we found two. There were two such pairs. Okay. Should we just let this one loose on the actual data? Hope for the best. Let's just check. Yeah, I'm just checking that it's able to read double digits. 441. Whoa! Okay. So let's go for part 2. I'm just going to be sure I don't screw up what works. Okay, part 2. It seems like there is still quite a bit of duplicate work planned. Instead, the elves would like to know the number of pairs that overlap. Okay, so it should be... I have a tendency to leap to conclusions, but I mean, they overlap. They overlap if this is an OR, doesn't that? So if the range start, let's see. No. Well, there's an OR, but it overlaps. Oh, wait, don't screw up part 1. Oh. Let's copy this to part 2. There we go. So it overlaps if the end of one range goes into the range, the start range of the other. So if this is the start of the first, so if the start of the first is beyond the start of the second, then they overlap, because okay. So we have an overlap either in this case or in this case. So it is symmetrical. So then if so the only thing we're concerned about is the stop of one range reaching into the start of the first one. So we have we're looking for intrusions here. So left intrudes on right if the end of this range is greater or equal the first one. That is enough. Or it is the right range uh, do, do, do. Oh no, we have two cases. Oh, this is the only two cases, isn't it? The left intrudes from the left, or the left intrudes to the right. My brain wants this to be a symmetric case, like in the part 1. Let's do it like this. Because the only thing we need to check if left range intrudes on the right range is if the left end boundary is greater than the right first boundary. And here right intrudes on left if right end boundary is greater than left. Okay, let's activate part 2. That doesn't look right. One, two, three, four, five, six. So 4 is not greater than 6. Yeah. This isn't enough. So in this case, it is, okay, it's a left boundary must be within the range of the other. So there we go. If the left boundary is beyond the second range start, but before the second range end, and the same here. There you have it. So here we check if the right range end is beyond the left range begin, but before the left range right. Okay. 2, 3, 4. So we have 1 here, the 7 intrudes, 2 to 8, 3 to 7, this one intrudes, this one intrudes, 1, 2, 3. Okay, let's see if there is, we get the right answer if we let this loose on the 861. Huh. Okay, I managed to not screw things up today, so that was good. So if you have, thank you for watching and see you tomorrow.
If you like my videos, feel free to do nothing.
Just grab a cup of coffee
and enjoy.